Hello everyone, welcome back to Deeksha Karnataka YouTube channel. Today I am going to discuss the top 30 questions from the chapter Electric Charges and Fields. This is a very important chapter. 4 questions every year comes from this chapter, and I have decided that for this chapter nothing better than to study the previous year questions. So all the 30 questions are from the previous year questions, and once this lecture is over you can download the PDF through our WhatsApp channel. So you have to join our WhatsApp channel. If you have not yet joined the WhatsApp channel, the link is given in the description. So join the WhatsApp channel. All the PDF will be shared through our WhatsApp channel only. So there will be a drive link shared to you. Once you get the drive link, you have to bookmark it, and for after each and every lecture the notes will be available there. So the thing is, once you download the lecture, there will be some extra questions for your practice, so you can practice those questions end of the PDF that you receive. Okay, so without any delay, let's start with today's session. First question is from KCET 2024. Okay, and as you can see, I have prepared this for all of you to understand the level of difficulty, how difficult the question is and how quickly you should solve this question. This question is based on Gauss law. It is a knowledge based question. 10 to 15 seconds is average time required to solve this question. So once you download the PDF, it will give you an idea that how well you are prepared to solve such questions, right? So the total electric flux through a closed spherical surface of radius r enclosing an electric dipole of dipole moment 2aq is. So dipole moment 2aq, so definitely plus q and minus q, so total charge enclosed is 0, so the net flux will also be 0. So the correct answer is option A. So very easy question. Just reading the question gives you an answer, so you don't need to worry whatever else is given in this case. Just understand the concept and you can answer such questions. Now next question. Again, it's an easy question, though a mixed level question, but it's a knowledge based question. That means if you have to understand, you have to know the concept to answer such question. Under the electrostatic condition of a charged conductor, which among the following statements is true? So very important true and false questions. So here only one statement is true, so you have to read all the 4 statements, and rest of the 3 are false. The electric field on the surface of a charged conductor is sigma by 2 epsilon naught, where epsilon is the surface charge density. So this is correct. The electric potential inside a charged conductor is always 0. So this is a wrong statement. Electric potential inside a conductor is not 0. It is constant. Electric field is 0. Okay, not the electric potential. So definitely we have found our answer, but for the sake of knowledge we will check the other 2 options as well. Any excess charge resides on the surface of the conductor. Yes, that is also correct. All the excess charge stays on the surface of the conductor. Net electric field is tangential to the surface of the conductor. That is also correct. So if you consider any electric field is always tangential to the surface of the conductor. So this statement is also correct. So I think the question is wrong. It will be false. Okay, which of the following statement is false? This statement is false. Other than that, all the statements are correct. Okay, so this statement is true, this is true, this is true. So the question should be which of the following is false, right? Now let's move on to the next question. A uniform electric field E equals to 3 into 10 to the power of 5 Newton per coulomb is acting along the positive y-axis. The electric flux through a rectangle of area 10 cm into 30 cm whose plane is parallel to the zx plane is. So very easy question. So electric flux is basically E into area, E into dA generally, but here the direct area is given. So electric field into area is the electric flux. They ask you to calculate the electric flux. Now remember that here the distances are given in centimeter, so you have to convert it into meters. That is the only thing that you have to do. So electric field is given by 3 into 10 to the power of 5. Okay, and then you have 10 centimeter into 30 centimeter. but once you convert it into meter, both will have 10 to the power of minus 2 associated with it. Okay, so 10 into 10 to the power of minus 2 meters into 30 into 10 to the power of minus 2 meters. So this is what you have to remember to solve this question. Other than that, this is very easy. So what you will get? You will get 30 into 3 is 90, 90 into 10 is 900 into 10 to the power of 5, 10 to the power of minus 4. So it will be 10 to the power of 1, that is only 10. So you will get the answer as 9 into 10 to the power of 3. 10, 20, 30, so 10 to the power of 3. So 9 into 10 to the power of 3 voltmeter is the unit of flask. Okay, don't worry too much about units. As long as you have converted all the units into SI units, you don't need to worry too much about it. Now next question. Obviously, before going to the next question, if you want to practice more and if you want to practice in a timed manner, that okay, 60 questions I require to answer in 60 minutes and my preparation should be complete, then definitely you have to consider using Abhyas KCET test series, which is available for a price of 1498. Go to the link given in the description and register yourself right now, and you can get access to all the questions. There is a schedule. According to the schedule, you will get the questions, and it is not overburdening. All the papers will come on time, and once you receive the question, you can start answering those questions and you can get better prepared for your KCET 2025 exam. Okay, so this is a very good platform. We are coming every day, not every day, we are coming live in every 2-3 days exclusively for Abhyas students, and we are clearing any doubts that you might have. So definitely register yourself, get the access and start answering and preparing for your rank less than 1000. And also there is a reward money for 1 lakh up to 1 lakh for rank up to less than 1000. Okay, so there is a detailed video on that as well, but I'm not going to discuss about that. You will get total 35 tests, 4 are free. So if you don't want to purchase right now, you can check out what all you are getting. So you can check that first 4 free tests, that is also available. Right, now let's move on. A body has a charge of minus 3.2 microcoulomb, the number of excess electrons in it. So this is obviously about the quantization of charges. Easy question, but requires some sort of calculation. So it requires at least 1 minute to solve this question. Now what we will use? We will use the quantization formula, that any charge is basically integer multiple of the basic charge, that is 1.6 into 10 to the power of minus 19 coulomb. Okay, so what is the charge given here? Given here is 3.2 microcoulomb. Only magnitude is sufficient. Sign is so if it is minus sign, that means extra electron. If it is positive sign, then it is less number of electrons. Okay, so that is the only thing. So microcoulomb means, micro means 10 to the power of minus 6. Okay, n into E is 1.6 into 10 to the power of minus 19. So n is basically 3.2 divided by 1.6 into 10 to the power of minus 6 plus 19. So this will come, everything will come to that side. So this 1.6 will be divided and this minus 19 will become positive, right? So this will be basically, you can see that 3.2 is cancelled with 2. So you will get 2 into 10 to the power of plus 13 number of electrons. Okay, so obviously correct answer is option C. And if you just see the numerical parts, even if you don't calculate the 10 to the power part, you can get the correct answer for this question. Maybe in some other questions you might not get that answer directly, so you have to calculate the 10 to the power as well. Now next question. It is again KCET 2024. So if you see that in 2024 we got 5 questions from this chapter alone. A point charge A of plus 10 microcoulomb and another point charge B of plus 20 microcoulomb are kept 1 meter apart in free space. Okay, the electrostatic force A due to B is F1 and the electrostatic force on B due to A is F2. Then obvious thing, we know that F1 and F2 will be equal but opposite. So suppose this is a positive charge, this is also positive charge, sorry, this is also a positive charge. Now if this charge is getting repelled, this charge is also getting repelled, so they are basically equal but in opposite direction according to the third law of Newton. So you can say this is F1 is equals to negative of F2. No doubt about it. 10 to 15 seconds you should take. As soon as you finish the question, reading the question, you should be able to answer this question. Now next question. Now we have came to 2023 questions. Okay, so as you see that questions are not super difficult from this chapter except 1 or 2 questions. There are some questions which are difficult. We will see that as well, but so far whatever questions we have seen are medium level to easy question. Electric field at a distance r from an infinitely long uniformly charged straight conductor having a linear charge density lambda is E1. Another uniformly charged conductor having same linear charge density lambda is bent into a semicircle of radius r. The electric field on its center E2 then. So there is a infinitely long wire, so the question is hidden in this. Okay, now if you bend that infinitely long wire, then again the radius of curvature will be again infinite. Okay, so basically at the center again it will have the constant electric field. We know that electric field is basically due to a straight wire is proportional to lambda by r. Okay, so if the distance remains same, then again we will get the same electric field. So E1 will be equals to E2, right? Now next question. A cubical Gaussian surface has side of length A equals to 10 centimeter. Electric field lines are parallel to x-axis as shown. So diagram is this is the diagram. Okay, so this is the electric field lines parallel to x-axis. Right, now you see that now electric field lines are parallel to x-axis as shown. The magnitude of electric field through the surface ABCD and EFGH are 6 kilonewton per coulomb and 9 kilonewton per coulomb. So from ABCD, this is ABCD, from this it is entering 6 kilonewton. Okay, and EFGH, there is a F, EFGH, it is 9 kilonewton per coulomb. Okay, so from this surface it is 3 kilonewton, 6 kilonewton per coulomb, this is 9 kilonewton per coulomb respectively. Then the total charge enclosed by the cube is, take epsilon 9 into 10 to the power of 12 for F per meter. Okay, so the value of epsilon naught is also given. So don't worry too much. Only thing you have to calculate is what is the flask. Okay, so electric field is given. Okay, electric field is given, flask is not given. So we know that change of flask or delta phi is basically Q enclosed by epsilon naught. Okay, so what is the change of flask? You have to calculate that. So change of flask is basically change in electric field into area. Area is constant in both cases. You can see that both surfaces are part of the cube, so both will have the same surface area, and length is given 10 centimeter. Okay, so what is the surface area? Surface area is 10 into 10 to the power of minus 2 into 10 into 10 to the power of minus 2. So it will be 10 to the power 2, 10 to the power minus 2, so it will be 10 to the power of minus 2. So this is a easy calculation, right? 100 into 10 to the power minus 2, basically 1, and another 10 to the power minus 2 still left, so 10 to the power of minus 2. So what is the flask change? Flask change is electric field. What is the delta E? See, 6 kilonewton per coulomb is coming in and 9 kilonewton per coulomb is leaving. So the change in the electric field is 3 kilonewton per coulomb. So kilonewton means, now you have to apply this thing, kilonewton. Kilo means 10 to the power of 3. Okay, so 3 into 10 to the power of 3 into area is 10 to the power of minus 2. So you get that change in flask is basically 30. Change in flask is 30. So Q enclosed is 30 into epsilon naught. Epsilon naught is 9 into 10 to the power of minus 12. So you get 27. You get that Q enclosed is equals to 27 into 10 to the power of minus 9. Right? Now let's check the answer. So if you see that it will be either plus 27 nanocoulomb or it will be minus 27 nanocoulomb. Right? Now how to do that? Obviously, I think there is some small mistake I have made. No, I have not made any mistake. It will be 270 into 10 to the power of minus 12. Okay? Minus 12. So it will be 0.27 nanocoulomb. Now what is the sign of this charge? Plus or minus. So if you see that the incoming flask is less, the outgoing flask is more. Okay, outgoing flask is more. So outgoing flask is more means definitely something inside which is increasing the flask. That means it is a positive charge. If incoming flask is bigger than the outgoing flask, that means it is a negative charge which is situated inside. Okay, so if the incoming flask and outgoing flask are outgoing flask is more, it will be positive. If outgoing flask is less, it will be negative. So correct answer in this case is option C. Okay, clear? Now next question. A positively charged glass rod is brought near an uncharged metal sphere which is mounted on an air insulated stand. If the glass rod is removed, the net charge on the metal sphere is very confusing but very easy question. So we have a positively charged glass rod is brought near an uncharged metal sphere. So glass rod which is positively charged, it is brought near a uncharged glass sphere. Okay, now it is mounted on an insulated, this is insulated, so for example it is a wooden stand. Okay, now the glass rod is removed. It was never touched. Remember, in the question it is not mentioned that they are touched with each other. So that means initially when this positive charge is brought, so there will be some induction happened. Induction, charging by induction. If you remember your lower class, so there will be some charging by induction will happen. But total number of positive and negative charge will remain same. Now once you remove this positively charged glass rod, these positive and negative charges will still recombine with each other, and the net charge will be a big zero. So net charge will be a big zero. Now let's move on to the next question. A tiny spherical oil drop carrying a net charge Q is balanced in still air with vertical uniform electric field of strength 81/7 pi into 10 to the power of 5 volt per meter. So the electric field is, so basically what is that? There is a drop. Okay, the electric field is 81/7 pi into 10 to the power of 5 volt per meter or Newton per coulomb. Okay, so this is the electric field. Now tiny spherical charge or net charge is Q. So the charge on this is Q. Okay, when the field is switched off, the drop is observed to fall with a terminal velocity of 2 into 10 to the power of 3 meter per second. So when you switch off the electric field, as soon as you switch off the electric field, the drop is falling with a constant velocity of 2 into 10 to the power of 3 meter per second. Okay, here G is 9.8 meter per second square. Viscosity of air is 1.8 into 10 to the power of minus 5 Newton second per meter square, and the density of oil is 900 kg per meter cube. So one good thing about this question is all the units are given in SI units. Okay, the magnitude of Q is, so this is very important part. Okay, so you have to understand that when this charge is at constant, that means the electric field is basically balancing the drag forces, okay, the drag force which is actually trying to keep it in the balance. Now direction of electric field may be in the opposite direction, that way I have drawn. So drag force which is trying to drag it in the air, okay, so suppose this is the drag force, okay, and this is the electric field, electric force, okay, they are balancing each other initially. Now once you switch off the electric field, the drag force is still there and it starts falling with that drag force, so that is why it is falling with the constant speed. Now you have to understand that this force on this charge, what is the force? Electric force. Electric force must be Q into E. Okay. Now what is drag force? Drag force is given by 6 pi eta r into V. Okay. 6 pi eta r V. So in this case I have just explained it little wrong anyway. Let me clear that. When the oil is static under the electric field, so electric field is acting in this direction, so electric field is acting in this direction, okay, and what is the electric force? Say Fe. And what it is balancing? It is balancing the weight of the drop, that is mg. Now in this case we do not need to calculate mg, even though g is given. M you can calculate, density of the oil is given, so volume, if you imagine volume V, you can calculate V, but that is not required. Why so? Because the next part it is saying that once you switch off the electric field, it is moving with a constant velocity. That means again when it is moving with the constant velocity, the drag force, that is 6 pi eta rv, is basically balancing its weight. Okay, so both of these forces, the electric force and the drag force, both are actually acting upwards, and both of them are basically balancing the same quantity mg. So mg, even though it is required, and one thing you have to remember that this is the question, this question is one of the most difficult question across the last 10 years of entire KCET exam. Okay, last 10 year entire KCET exam, this is one of the most difficult question throughout the KCET all chapters. Okay, so now that is why this is little complicated, that they both of them are actually balancing mg. Okay, but because they are equal, so we can say that because they both are balancing mg, so they must be equal. So we do not need to, even though the calculation wise this is not super difficult, you can solve it. Rv, now let's put the value. Q we are trying to find. E is 81 by 7 into pi into 10 to the power of 5. Then we have 6 pi. Okay, eta is I think 1.8 into 10 to the power of minus 5, and V is 2 into 10 to the power so 6 pi eta is 1.8 into 10 to the power of minus 5, and R value we do not know, and V is the velocity, terminal velocity. Here V is the terminal velocity, which is given by 2 into 10 to the power of minus 3. Okay, so 2 into 10 to the power of minus 3. Okay, from here you have to calculate the value of Q. Now there is one tiny problem, that we do not know the value of R. Okay, so as I said, this is not the easy question, not for the weak hearted. In year 2023, if you are appearing, then you have to skip this question. This is a very long lengthy question, not super easy to solve. Okay, so let's simplify it. 6 into 1.8 into 7, okay, divided by 81 into 10 to the power of minus 8 minus 13. Okay, 10 to the power of minus 8 minus 13 into R. Okay, now R value is very, very important. Now we can cancel a little bit. So for example, we can cancel it 0.2 into 9. Okay, and then we can cancel it 3 and 3, so it will be 21 into 0.2, which will be 21 into 0.2 is 4.2, right? Sorry, it will be 3 2s are 6, right? 3 2s are 6. So 14 into 2 is 28. 28 means there is a decimal, so 2.8. So 2.8 divided by 3 into 10 to the power of minus 13. I hope I have not made any mistakes in this calculation. Yes, I made one mistake, that the terminal velocity was 2 into. Terminal velocity was 2 into 10 to the power of minus 3, so I missed that 2 over here. So 2 into 10 to the power of minus 3, sorry. So there will be another 2 over here, so you will get 5.6 by 3. So you get that value of Q is 5.6 by 3, which is approximately, but still it is not the answer. You cannot guess the answer from here. So what you have you got that Q is basically equals to 5.6 divided by 3 into 10 to the power of minus 13 into R. So again, as I said, you cannot guess the answer from this. Neither 10 to the powers are accurate nor this value is accurate. So you have to wait and you have to find the value of R, right? Now how can we calculate the value of R? As I said that at any point of time at the beginning, okay, this electric field was equal to the weight of the spherical ball. So Fe, as I said, even though I thought it may not be required, but as I can see that it is required. So Fe, the electric field is electric force is equals to the weight, that is mg. This is the easiest one. You can use this value as well, but that will complicate the equation. So you can start. My mistake. Q we do not know, right? So we will not use this. We will use this one. This one is the easiest one. So drag force is basically equals to mg. What is drag force? 6 pi eta r into v. Okay, all the values are known here except r. Now what is m? As I said, m is basically volume of the spherical shell times the density. Volumes times density is the mass of any object. So density is basically mass per unit volume. So mass is volume into density. Now what is volume of a sphere? Volume of a sphere is basically 4/3 pi r cube into rho. Okay, so you have to put that value here as well. So 4/3 pi small r cube into rho and g. Okay, so using this you can calculate the value of say they are cancelled, and one of the r will be cancelled. You get r square over here. So r square equals to 6 into 3 divided by 4, okay, into eta. Eta is 1.8 into 10 to the power of minus 5. Tiny spherical ball, so it will be very, very small. So eta is 1.8. V is 2 into 10 to the power of minus 3 divided by rho g. Rho is 900 and g is 9.8. Okay, so this is how you are going to get the values, right? Now let's see how can I cancel these values. Now this is r square. Okay, so you have to take into account that if you can do a square root of anything, that will be very, very good. For example, you can take that 2 out and you can make it 49 for 4.9. Okay, so what we will do, we will try to separate whatever is not multiple of 2 and we will cancel that out, right? So what is this? This will be 6 into 3 into 6 is 18, and if you take this decimals out, then we have another 18 over here, right? So we have included 18 over here, and there is nothing else is here. 10 to the power of minus 5, minus 3, minus 8, I think the board is getting jumbled. Okay, let me clear this part, because this part is okay, you can understand that. This not major calculation is here, but I don't want to erase the calculation, so that once you download the PDF you get entire calculations as it is. Okay, so you get r square is equals to 18, so 18 into, we have removed the decimal from top and bottom, so we have 18 over here, another 18, and 10 to the power of minus 5 minus 3, that is 10 to the power of minus 8, divided by 4 into 9. Now 900 we are writing it in as like this, into 10 to the into 49. Okay, so this is the value of r square. So what is the value of r? Value of r will be 18. So for each pair we will be taking 1, right? Divided by 4 square root is 2, 9 square root is 3, and 100 square root is 10, and 49 square root is 7, not over 10 to the power of minus 8 square root is 10 to the power of minus 4. So as you can see, this is getting slightly complicated. So there will be cancellation as well, 9, and then again cancellation 3. So it will be and this will go up and it will become 10 to the power of minus 5. So what is the value? You will get 3 by 7 into 10 to the power of minus 5. Okay, so this is the value of r. So as you can see, this is very, very small, obviously meters. 3 by 7 into 10 to the power of minus 5 meters. So now we have to put that value. So 5.6 by 3 into 3 by 7 into 10 to the power of minus 5 into 10 to the power of minus 13. Okay, so you can cancel these 3. So you get 5.6 divided by 7 into 10 to the power of minus 18. Okay, so 56 divided by 7 is 8, but here we have 5.6, so answer will be 0.8 into 10 to the power of minus 18, or it will be equal to 8 into 10 to the power of minus 19. So if you see the values, if you solve it properly, okay, the calculation part is okay, but the main problem of this question is it is a very, very lengthy question, and by that time you solve this question, you can solve at least 4 other questions. This is not super easy question, but if you see similar questions in KCET, if the exact question comes, which is very unlikely, then you know the answer, but if does not come, then obviously you can skip such questions. This is a very strict no for your solution. Okay, if you have solved all the questions and if you still have some time, then you can attempt this question. Okay, other than that, you don't waste your time in this long unstandard question. This is, as I said, this is one of the most difficult complex question across all the KCET last 10-year question paper. Now let's see. So this is a medium level question based on dipole formula and calculations, everything. You can make mistakes on this. An electric dipole with dipole moment 4 into 10 to the power of minus 9 coulomb meter is aligned at 30 degrees with the direction of an uniform electric field of magnitude 5 into 10 to the power of 4 Newton per coulomb. The magnitude of the torque acting on the dipole is. So electric field is given, the dipole moment is given, and they asked you what is the torque. I don't think that 1 to 2 minutes is required. So torque is basically PE sine theta. Right, now I guess that they are given in the same angle is given 30 degrees. Okay, so P is sine theta, not same direction, so be careful. So P is 4 into 10 to the power of minus 9, E is 5 into 10 to the power of 4, and sine 30. Sine 30 is half. Okay, you don't need to write everything like that the way I am doing, but if you just write directly half, if I write directly half, you will say, sir, how this half came? So for that I have to explain you, this half came from the fact that this is sine theta equals to half. Okay, so it will be cancelled, so you will get 10, so it will be 10 to the power of minus 4. Okay, so the torque is 10 to the power of minus 4 Newton meter. Okay, so the correct answer is option B, not this option C. So even if you get 10 into 10 to the power of minus 5, that means it is 10 to the power of minus 4. So it is just 10 to the power of minus 4, right? Now, next question. 4 charges plus Q plus 2Q plus Q and minus 2Q are placed at the corners of a square ABCD respectively. The force on a unit positive charge kept at the center O is. So we have to find the direction or determine whether it is 0 or not. So this is a diagram question. You have to check the diagram first. Without drawing the diagram you cannot solve it. So this is the square. So plus Q, let me draw it like this, plus Q, then we have plus 2Q, okay, then we have plus Q, and then we have minus 2Q, and the name is very important, A, B, C, D. Same order, whatever order is given for the charges, same order we will use for the name as well. Now if you keep a charge at the center, center means where these two diagonals meet, right? So this is the center. If you keep a charge, positive charge, unit positive charge at the center O, then what will be the direction of force on this charge? So as you can see that this positive charge will attract it in this direction, and this positive charge will attract it, my mistake again, sorry. This positive charge, this is positive, this charge is also positive, right? So what will happen is, this is also positive. So this positive charge will repel it in this direction, and this positive Q will repel it in this direction. And both charges will be equal in magnitude. Why? These two distances are equal, like diagonals are diagonals intersect each other in equal halves, so these two distances are equal. So that is why we can say that the force for A and C direction are cancelling each other, so there will be no force in this direction, they cancel each other out. Now what about this positive charge? This positive 2Q charge, it will repel it in this direction, okay, this will repel it. And what about this 2Q charge? This 2Q charge will attract it in this direction, okay. So both of the forces due to this diagonal, both are along OD or BO, both are same direction, right? So either BO or OD. Okay, now let's see what is the given option. Along the diagonal AC, no. Perpendicular to AD, no. Along the diagonal BD, it is along the diagonal BD, yes, so it is along the diagonal BD, so definitely option D is the correct answer for this question. Okay, so just draw the diagram, identify what are all the forces getting cancelled and what are all the forces that still remain, and based on that you can answer. So this is the conceptual question, answerable, not super difficult. If you just understand the concept, you can answer such questions. A charged particle of mass m and charge q is released from the rest in an uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds. This is also very interesting, not easy question, medium question and slightly lengthy question. So charged particle, the mass of the charged particle is m. So mass is given in this case, q is given, so charge is given, and after released from the rest, the electric field is E. Okay, so now you have to neglect gravity, neglect air resistance, everything you have to neglect. You have to calculate the kinetic energy of the particle. Okay, so you have to find half mv square. Kinetic energy means half mv square. So you have to find the velocity after t second. That is the only way to calculate the kinetic energy. How to do that? So first, when you keep it in an electric field, what it will experience? It will experience electric force. So what is that electric force? The electric force is basically, see, the concept is about electric force. So electric force is Q into E. So this is the force experienced by the charge. So as long as there is a force, as I said, father equals to ma. So QE will be equals to ma. From here you can calculate the acceleration is QE by m. So this is the acceleration. Okay, now after, so initially it starts from the rest. So initial speed is 0. So u is 0. What is v? You have to find v. So how to do that? We know that v is equal to u plus at, the old first Pew formula, the most important formula, the equation of motion. Now what is v? V is u is 0. A we have calculated, QE by m, and time is given in this question after time t. So this is the velocity after time t. So it is QE t by m. Now you have to put this over here. So half m into QE t by m whole square. Okay, formula for kinetic energy is same, no tricks here. Now you have to put it half m into q square e square t square by m square. Now m square means one of the m's will be cancelled. So what is the value? Q square e square t square by 2m. Okay, so if you stay careful, if you understand the question, then you can answer it. Okay, I think there is, it will be t square, not r square. So q square e square t square by 2m. So option C is correct answer. Okay, so this is how you solve such questions. But just concentrate on the question, what is given, what is asked. So for that you have to practice, right? And Abhyas is giving you that opportunity. So if you have not yet subscribed to Abhyas, go do it right now. Which of the statement is false in the case of polar molecules? Centers of positive and negative charges are separated in the absence of external electric field. Okay, so polar molecules, and we are trying to find false statement. Okay, very, very important. So the centers of positive and negative charges are separated in the absence of external electric field. Yes, it's correct. So as we know that polar generally have a positive and negative, they do not coincide. For non-polar they coincide, but for polar they already separated. Centers of positive and negative charges are separated in the presence of external electric field. Yes, if they are present, they are separated already. Okay, even if you apply some external electric field, they are still remain separated. Do not possess permanent dipole moments. So because their centers are separated, positive and negative, definitely they possess a permanent dipole moment from positive to negative. So this statement is incorrect. So option C is the false statement. Let's check the option D as well. Ionic molecules, HCl is an example of polar molecule. Yes, HCl, I gave you that example in my lecture as well. HCl, H is plus, Cl is minus. So definitely this is an example of polar molecule. So option D is, option D is a correct option, not false statement. Okay, this is not a false statement, this is a true statement. We are only identifying the false statement. So option C is correct. Now next question. An object of mass 2 grams located in a region of uniform electric field E is equal to 300 Newton per Coulomb I cap carries a charge Q. The object released from the rest at x equals to 0 has a kinetic energy of 0.12 joules. Okay, at x equal to 0.5 meter. Then Q is, so you have to find the Q in this case. Okay, and they have given you the displacement. After the displacement, what is the kinetic energy? Now this is also looking similar to that of E square Q square T square by 2m, but here the difference is that here we do not have the time is not given. So how to solve if the time is not given? That is also a thing that you have to know. So Q or we are trying to find. So what is the force? Again the same concept. Force is Q into E. Okay, force is Q into E. Same direction along the x-axis. I cap represents along the x-axis. The displacement also represents along the x-axis. So we are not using the vector form. Okay, so it is basically 300. So the force is 300 Q. Now, if the displacement is 0.5 meter under the influence of this constant force, then what is the work done? The work done is force into the displacement. That is 300 Q into 0.5 meters. That is 150 Q. Okay, 0.5 means basically half. So half of 300 is 150. So these are the things that you have to remember in the heat of the moment when you are solving the questions. Right now maybe you will be able to understand how, sir, you have written this. So these are the small tricks, small calculation tricks that you have to remember. So now this is the work done. Now work energy theorem, first view again, work energy theorem says that whatever is the work done, that should be the change in the kinetic energy. Right, whatever is the work done, that should be the change in the kinetic energy. So what we will do, we'll put the same work done, that is 150 Q equals to, now kinetic energy is given by 0.12. Initial kinetic energy was 0 starting from rest, final kinetic energy is 0.12. So this is the relation that we are going to use in this case. So Q is basically 0.12 divided by 150. Okay, not difficult. Okay, if you know what you are doing, you can answer that this kind of questions. Now you have to just solve it. 12 into 10 to the power of minus 2 by 15 into, so you can take that 10 to the power of minus 3, that 0 will go up and negative. Now you have to cancel it. Okay, so you will get 3 4s are 12, 3 5s are 15, and so that will be 0.8 into 10 to the power of minus 3, or it will be 800 microcoulomb. Okay, so 800 microcoulomb. Next, electric field due to infinite straight uniformly charged wire varies with distance r as. So this is a very easy question. Electric field due to a straight wire varies with lambda by r, so it is inversely proportional to the distance, so it is 1 by r. So B is basically 1 by r. Even 10 second is more for this question. Right, now a copper rod AB of length L is rotated about end A with a constant angular velocity omega. The electric field at a distance x from the axis of the rotation is. Okay, so what is happening here? You have a copper rod. Okay, a copper rod AB of length is L and is rotated about end A. So from here we are rotating it. Okay, so we are just rotating it from the end A. The electric field at a distance x from the axis of rotation. So suppose this is the axis of rotation and we are trying to find electric field at some distance x. Okay, now in this question there are two things missing. So basically you can consider this is slightly incomplete question. First of all, this distance x is cannot be outside the wire, outside the rod. It should be somewhere within the rod, so that is not specified. So it is rotating, suppose along this axis. The distance x should be less than that of the distance x should be less than that of the length of the rod. That is one thing. Secondly, this m is not the mass of the rod, this m is the mass of electron. That is also should have been specified over here. So suppose what we will do, we will try to find, suppose we will take one electron located at this position. So if this rod is rotating at the angular speed omega, every point on this rod will also rotate with the same angular speed omega, right? So so uniform angular speed means that all the points rotate with the same angular speed. Now suppose this is the distance x. Now we consider a small electron located here, right? Now this small electron will also rotate with the same angular speed omega. Now when an electron is rotating in an angular motion, there is a force acting on it. What is that force? That force we call it centripetal force, and this is m omega square, okay, into r. Omega square into r. So here it is x. Instead of r we will write x because we are considering the distance x from the rotation, right? So this is the m omega square x. So this is the force. Now centripetal force is something which has to be provided by something some external agency. Okay, centripetal force is required for rotational motion and it has to be provided by something, some other means. So what can provide the required centripetal force for this motion? So only one thing that can provide the required centripetal force, that is the electric force. So if the electric field at this point say E, then that electron will also experience an electric field of E into E, right? So the electric field also the charge will also experience the force E into E. So basically we are saying that the force experienced by the electron must be equal. So we just need to compare these two. So E into E is basically m omega square into x. Now as I said, this m is the mass of the electron, so that is not clear over here, and also the distance x should have been mentioned as the less than L, that is also not mentioned. Okay, so it is partially incomplete. So m omega square x by E, option A, is correct answer for this question. Now you know the answer, so if you see similar question, so you can answer such questions, right? Now next question, when a soap bubble is charged, the radius remains same, the radius increases or decreases, the radius increases, the radius decreases. So if you charge a soap bubble, all the charges will remain where? On the surface of the soap bubble, right? So surface of the soap bubble means now these two charges will repel each other, they will try to go away from each other. Similarly, they will also repel, they will also repel. So what will happen is that this soap bubble, the radius will slowly increase till it bursts. Okay, there is nothing inside the soap bubble, air inside it, so its radius will always increase. Okay, radius will increase or radius increases. Now let's see this question. An electric field lines on the left have twice the separation on those on the right as shown in the figure. If the magnitude of the field at A is 40 volt per meter, what is the force on 20 microcoulomb charge kept at B? So it is shown here that the gap here is, suppose the gap between the two field is say x, okay, then the gap here is 2x, that was given, right? So if the gap here is x, then the gap increases to 2x. Okay, that means the electric field, if the electric field here is say E, the electric field here will be E by 2. Electric field is directly proportional to the gap between the field lines. That is one of the properties of electric field lines, right? So more stronger the electric field, closer they are, okay, weaker the electric field, further they are, okay, and that is proportional. The gap is proportional to the strength of the electric field. So if we know the relative distances, we can say how weak it is compared to the other electric field. So electric field here is given E, then this will be E by 2. So first of all, let us see the electric field here. Electric field at A is given 40 volt per meter. So electric field at B is basically 20 volt per meter, half of that, right? Now what is the force on a 20 microcoulomb charge? If you keep it at here, then the force on 20 microcoulomb charge at B will be charge times the electric field. That is the old formula. So charge is 20 microcoulomb, so 20 into 10 to the power of minus 6, and electric field is given by 20 volt per meter. Okay, so it will be 400 into 10 to the power of minus 6, or it will be 4 into 10 to the power of minus 4 Newton. Okay, so unit of force is Newton, so 4 into 10 to the power of minus 4, 2 zeros will less, right? So you have to be careful. Next question, a point charge Q is placed at the corner of a cube of side A as shown in the figure. What is the electric flux through the face A, B, C, D? So you have placed a charge in the corner of a cube. So if suppose you have placed the charge at some point D. Okay, now you want to find what is the flux through this ABCD surface. Okay, ABCD surface. You might be saying, sir, it may be 0, it may be Q by epsilon naught, but how to know that? Okay, so first of all you have to understand that there is 2 ways to solve it. First of all, you can understand that if you consider a cube and if you place, say, at one corner, okay, you can consider new Gaussian surfaces of same side on the left side, on the right side, on the top side. So all the sides you can consider. So it will be, you can consider, so imagine you have one dice, okay, 1 2 3 4 5 6 that you play in Ludo game, right? So there is a dice. Now if you can stack more dices on the all the surfaces so that it's a symmetric figure, and total number of dice will be 6, right? Total number of dice, if you place on all the surfaces, total number of dice covering this point will be 6, right? So the electric flux through each of them will be 1/6. Okay, so basically electric flux for a spherical surface, or if it is a complete surface, it will be Q by epsilon naught, but here the surface area is also important. Okay, so electric flux will be Q by 6 epsilon naught, Q by 6 epsilon naught, because in that case 6 other cubes are occupying the same space. So answer will be Q by 6 epsilon naught. Next question. An infinitely long thin straight wire has uniform charge density of 1 by 4 pi epsilon naught 1 by 4 into 10 to the power of minus 2 coulomb per meter. What is the magnitude of the electric field at a distance 20 centimeter from the axis of the wire? Okay, so the charge density is given as 1 by 4 into 10 to the power of minus 2 coulomb per meter. Okay, what is the magnitude of electric field at a distance 20 centimeter from the axis of the wire? So this is a long wire, lambda is given 20 centimeter. 20 centimeter means 20 into 10 to the power minus 2 meters. Okay, now what is the electric field? Electric field is basically given by 1 by 4 pi epsilon naught, okay, 2 lambda by the distance r. That is the formula, right? Now you can cancel these two, and you can say 2 pi epsilon naught. That is also fine. I like to remember it this way because 1 by 4 pi epsilon naught is a constant. So that is how I remember. You can remember this, or you can remember the formula given in your textbook, that is 1 by 2 pi epsilon naught lambda by r. That is also fine. Okay, but for solving numerical, this is easier to remember. Now 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. Okay, 2 lambda is given by 1 by 4 into 10 to the power of minus 2, right? And then we have that distance. Now that is not square. Remember that for straight wire it is not square, it is 20 into 10 to the power of minus 2. So this 10 to the power minus 2, this 10 to the power minus 2 cancels. Okay, you can cancel one of them as well, so you get 10. Okay, so you get 9 by 4, this 10 will cancel one of the zeros, it will be 10 to the power of 8. Okay, so this 10 and 10 to the power of 9, so 1 0 reduced, so 10 to the power of 8. Now this 1 by 4 is only left, everything else is cancelled, right? So this 1 by 4 will be 9 by 4, so 9 by 4 means 2 4s are 8, there will be 1, so 2.25 into 10 to the power of 8. Okay, so 2.25 into 10 to the power of 8 Newton per Coulomb is the answer for this question. We have already solved 20 questions so far, right? Now let's move on to the last few questions. An electric dipole is kept in non-uniform electric field. It's generally experienced. Again, if you keep the dipole in a non-uniform electric field, it will experience both force and torque. So it will experience both force and a torque. So a force and a torque is the answer. Okay. So be careful. This is a repeated question. So this kind of question we saw it twice. Even though easy question, but we see this question coming repeatedly. A certain charge 2q is divided at first into two parts, small q1 and small q2. Later the charges are placed at a certain distance. If the force of interaction between the two charges is maximum, then q by q1 is equals to. So very interesting question. So if you have a charge capital Q, okay, and if you want to get the maximum charge, in this case we have 2q, okay, if you divide it into two halves and you want to take that the force is maximum between the charges, then you have to divide the charges into two equal parts. In any other combination the force will not be maximum. Okay, so you have to understand that whenever you have a single charge, okay, you divide it into two halves, and if you want the force to be maximum between them, then what you have to do, you have to consider that the charge should be divided into equal parts. Only if you divided them into equal parts, the force will be maximum. So in this case the force will be capital Q, another will be also capital Q. So the small q1 equals to this, q2 will be also equals to q. Okay, so what is the ratio of q by q1? So ratio of q by q1 should be equals to 1. That is the only way. Okay, so both of them should be equals to the half of the given charge. So that is, in this case, half of the charge is capital Q itself. So q by q1 will be 1. Next question. The force of repulsion between two identical positive charges when kept with a separation r in air is F. Half the gap between the charges is filled by a dielectric slab of dielectric constant 4. Then the new force of the repulsion between those two charges becomes. So first they have said that initially they are kept at a distance r and the force is given by F. So two identical positive charges, so q square by r square, right? Identical charges, I am assuming both charges are q. Now what happened is that you have filled 50% of the charge, 50% of the space with the dielectric constant. Suppose this is the q, this is another q. You have filled 50% of them. So total distance was r now it is r by 2. R by 2 has a dielectric constant of say 4 and 4, and other half is left with the same space. Okay, now there is a trick you can remember using the formula. I will tell you the formula, but first I will tell you the concept behind it, how to solve it. Okay, you have suppose you have two charges q1 and q2. Okay, they are separated by a distance small r. Okay, they are separated by a distance small r. Okay, initially they are in air, so the force between them was 1 by 4 pi epsilon naught q1 q2 by r square. Okay, so this is the initial force between them. Now if you add a dielectric slab completely, not half, you add a dielectric slab completely of say dielectric constant K, then what will be the new force? The new force will be 1 by 4 pi epsilon naught, okay, not epsilon naught, sorry, epsilon into Q1 Q2 by r square. Now what is epsilon? Epsilon is basically nothing but K into epsilon naught, right? Now let's put that value over here. So you get 1 by 4 pi K epsilon naught Q1 Q2 by r square, or you get 1 by 4 pi epsilon naught Q1 Q2 by root K r whole square. Okay, so this is the new equation. Now if you see that here we have restored our order, we have got back our 1 by 4 pi epsilon naught, that is the free space equation. So this root K into r is called the equivalent free space length, right? So if you put a dielectric constant 4 over here, then for this r by 2 the equivalent length will be root K into r by 2, and remaining r by 2 is already in here, so you have to add it like this. So this is the formula. Okay, the formula, if you are interested in, it is very handy formula actually. That is, you have a space, two charges separated by a distance q1 and q2, and you fill suppose x of it with a dielectric constant K. Total distance is r. Okay, now what is the force between them? The force between them will be 1 by 4 pi epsilon naught, definitely this is the constant, q1 q2 divided by root K into x plus r minus x, okay, whole square. This is the formula for the entire distance. Okay, this is the new formula for force. Now here in this problem, x is basically r by 2, so r minus r by 2 is also r by 2, so you can say that this will be the distance, new distance, right? So initial force was this, the final force will be, let me put that. So the dielectric constant is given such a way, it is a whole number, so that you can take the square root of it. So square root of 4 is 2, so 2 into r by 2 plus r by 2. Okay, this is the main formula that you have to remember. So 2 cancels, you get 3r by 2. So entire thing is, there is a square also, so you get, I am writing it k q square, I am too many times 1 by 4 pi epsilon naught, so 3 by 2 r whole square, so it will be 4 by 9, okay, into f. So obviously q square by r square is kq square by r square is f, and this is 9 by 4, so if you take it opposite it will be 4 by 9. Okay, so it will be 4 by 9. So it will be 4 by 9 into f. So correct answer is option D. Little long, but you can solve it quickly if you remember the formula. The magnitude of point charge due to which the electric field is 30 centimeter away has the magnitude of 2 Newton per Coulomb will be. So you have to find the charge for which the electric field at a distance 30 centimeter will have a magnitude 2 Newton per Coulomb. Okay, so electric field is 2 Newton per Coulomb is equals to K Q by R square. So Q will be equals to 2R square by K. Okay, so just put the value 2 into R square is 30 centimeter. 30 centimeter is nothing but 30 into 10 to the power of minus 2 whole square divided by 9 into 10 to the power of 9, or just do it 2 into 900 into 10 to the power of minus 4 divided by 9 into 10 to the power of 9, 9 cancel, you get 100. So 100 10 to the power of minus 4 is 10 to the power of minus 2, and you get this 10 to the power of minus 9 will go up, so it will be 10 to the power of minus 9 here. So 2 into 10 to the power of minus 11 is the answer. So 2 into 10 to the power of minus 11 is the answer. So quickly you can solve it if you practice. 3-point charges of plus 2q and minus 4q are placed at the corners A, B, C of an equilateral triangle. So this is an equilateral triangle, and you have placed 3 charges, 2q, another plus 2q, and another is minus 4q. Okay, and they ask you what is the magnitude of the electric dipole moment of the system. Okay, side is x, so the magnitude of the electric dipole moment of this system. Now this is angle is 60 degrees, obviously equilateral triangle. Now how to do that? So they are, even though the combination is weird, we can divide this minus 4q into 2 parts. Okay, minus 2q over here and minus 2q over here. So combined both, it is minus 4q still, and we know that this minus 2q and this plus 2q will form one dipole moment, and that direction will be in the direction from negative to positive. Again, this minus 2q and this plus 2q will form another dipole moment, and this direction will be again from negative to positive. So you can divide it like this to find the equivalent dipole moment. Now both of these dipole moments are of equal magnitude. So what is the value of this? Suppose this is P. What is the value of P? P is any one of the charge times the distance between them. Any one of the charge is 2q times the distance is x. Similarly here also it will be 2qx. So both of the dipole moments are of equal magnitude. So equal magnitude means you have to calculate the resultant, by the way. So resultant will be along this direction. Okay, so if you take the resultant of this component in this direction and in the perpendicular direction, perpendicular components will be cancelled, only the cos components will be remain, and cos component of cos 30. Okay, so this is similar to that of the dipole along the axis. If you remember, dipole on the perpendicular bisector, perpendicular equatorial plane. So same here as well. So these two angles will be equal, okay, because this is the perpendicular bisector. Angular bisector, so it is dividing the angle into 2 halves, and both components are cos components because this is also 30, this is also 30. So if you take the component on this, adjacent angle is 30, and if you take the component of this on this, again adjacent angle is 30. So it will be 2p cos 30. Okay, 2 because one from this, one from this. So p cos theta plus p cos theta, 2p cos theta, right? So 2 into 2q x into cos 30. Cos 30 is root 3 by 2. Cos 30 is root 3 by 2. So one of the 2's cancelled. So you get 2 root 3 q into x. 2 root 3 q into x. So correct answer is option A. Next question. 4 into 10 to the power of 10 electrons are removed from a neutral metal sphere of diameter 20 centimeter placed in air. The magnitude of the electric field in Newton at a distance of 20 centimeter from its center is. Okay. Now if you see that question appears to be slightly tricky. Okay, diameter is given to 20 centimeter, but the distance is given also 20 centimeters. So you might think that, oh, the point is located on the surface of the sphere. So, and you might think that it is very complicated, because on the surface of the sphere the electric field is not continuous. If you are going from inside, it will be 0. If you are coming from outside, it will not be 0. But actually this is a trick question. The diameter is given 20 centimeter. That means the radius is basically 10 centimeter. Okay, and you are given a point outside the sphere which is at a distance of 20 centimeter. Okay, so basically you can consider all the charge on the surface is located at the center. So electric field is basically kq by r square. Now you have to calculate the q first. Q is not given. It is given that number of electrons removed is 4 into 10 to the power of 10. That is given. So n is given 4 into 10 to the power of 10. E is 1.6 into 10 to the power of minus 19. So it will be 6.4 into 10 to the power of minus 9. Okay, 4 16s are 64. There is a decimal, so 6.4. Okay, so this is the charge. Now we have to put the values. So K is 9 into 10 to the power of 9, and Q we have already calculated, 6.4 into 10 to the power of minus 9. So they cancel, and distance is given 20 centimeters. So 20 centimeter means 20 into 10 to the power of minus 2 whole square. So it will be 9 into 6.4. You can cancel one of them. Okay, you can cancel one of the zeros, so it will become 2 into 10 to the power of minus 1. So 2 square is 4, and 10 to the power of minus 1 whole square is 10 to the power of minus 2. So you can again cancel one of them, so 1.6. So 1.6 will be 13.9 plus 14.4 into 10 to the power of 2. So it will be 1440. Okay, 1440 Newton per Coulomb. Now how I calculated, if you are still not understanding how I have calculated, so this one is clear, right? I have cancelled 1 0 and 10 to the power of minus 2 over here, so one of them is cancelled, right? So it is 10 to the power of minus 1 here. Now 2 square is 4, 10 to the power of minus 1 whole square is 10 to the power of minus 2, right? Now what else? Now we have to complete this multiplication. So 9 ones are 9, we know that. 6 nines are 54. Okay, so 6 nines are 54 means 9 plus 5.4. Okay, so this was 0.6, so 0.6 into 9 is 5.4. So you will get 9, this 9 will come whole because this number is whole number, so 1 into 9 is 9, 0.6 into 9 is 5.4. Okay, so now you have to add them, so you get 14.4. Okay, so you just divide in small multiplications, you can divide the whole number and the decimal number and individually multiply them to the number, and then you can add them up to get the correct answer, right? Now next question. Two spheres of electric charges plus 2 nanocoulomb and minus 8 nanocoulomb are placed at a distance small d apart. If they are allowed to touch each other, what is the new distance between them to get a repulsive force of the same magnitude before? Now they should be, first of all, they should be identical spheres so that the charge distribution is same. So plus 2 nanocoulomb and minus 8 nanocoulomb placed at a distance d apart. Okay, so what is the initial force? So initial force is K into 2 into 8 by d square. Now we are ignoring nanocoulomb, we are ignoring everything else not required because actually we are going to compare. So all the nanocoulomb etc. will be cancelled, and sign is also not required. Now once you touch them together, so one has plus 2, another had -8. Okay, once you touch them together, what will happen is that the net charge will redistribute. So net charge redistribute means what is the net charge? Net charge will be -8 plus 2, that is -6. Now both of the spheres will have the same charge. So both of the spheres will have same charge, that is -6 by 2, that is -3. So both of them will now have -3 amount of charge. So what is the new force? Now the distance say, now the new distance say x, so that both of them are having the same amount of repulsive force. Okay, so both these forces are same, so you have to compare. So k into 16 by d square equals to 9 by x square. So x square is equals to 9 by 16 d square. So you get the cross multiplication, simple cross multiplication. This comes up, this goes up, this 16 comes down. Okay, so x equals to 3 by 4 into d. So it will be 3 by 4 into d. Okay, 3d by 4. Okay, 3d by 4 is the new distance. Next question. If E axial and E equatorial represents electric field at the point on the axis, on the axial and equatorial line of the dipole, if the points are at a distance r from the center of the dipole for r greater than a, we know that axial electric field is stronger and it is twice that of the equatorial plane. Not only that, it is obviously on the opposite direction. So electric on the axial is positive, electric field on the equatorial plane is on the opposite direction. So basically they are this is twice strong as that. So if this is equipotential and if this is E axial, so E axial is basically twice that of E potential. So this is stronger. Okay, and also this is a negative sign. So correct answer is option C here. Okay, next question. An electron of mass m, charge E, falls through a distance h meter in an uniform electric field E. Then the time of fall. Another interesting question, very interesting question. Okay, so electron of mass m and charge E falls through a distance h meter in a uniform electric field. The force is electron, right? Electron means E into E. So this is the force. This is the force experienced by the electron, and that should be equals to the acceleration into mass. So acceleration is E by m. So this is the acceleration of the electron. Now how much distance is traveled? It traveled a distance h. So we know that s equals to ut plus half at square. Right, we are trying to find the time, but initially it started from rest. So u is 0. So h and the distance fall is h. So h equals to half into E by m into t square. So from there you can say that okay, t square is equals to 2h. Okay, and this m will also go up, 2hm divided by EE. So T is basically square root of 2hm by charge of electron into electric field. So 2hm by EE, correct answer is option A. If there is only one type of charge in the universe, then E is electric field, ds is area vector. E dot ds is not equals to 0 on any surface. E dot ds could not be defined. E dot ds is equals to infinity if the charge is inside. E dot ds equals to 0 if charge is outside, and q by epsilon naught if charge is inside. So as you can see that they are saying E dot ds is not equals to 0, which is not possible. If the surface is neutral, then definitely, or it does not contain anything, definitely it can be 0. And as you can see, this is the statement of Gauss's law given in a separate way. So this is always true, does not matter one type of charge is there, 3 types of charges there, 5 types of charges there. Gauss's law is universal law, it is always correct. So option D is the correct answer for this question, right? And if you want to practice more such questions, definitely you should consider purchasing Abhyas test series, where you will get real test like feel along with all the good questions across all the chapters of your P1 and P2 syllabus, right? With this note, I am ending this lecture, and if you have liked this lecture, don't forget to give it a thumbs up, and obviously subscribe to our channel if you have not yet subscribed. And if you have any questions, mention that in the comment below. I will see you in a new video very soon. Till then, bye.